The atom. What is it, and how has it changed over time? We start with Greek philosopher, Democritus. Yes, it's always the Greeks, and yes, he did influence laws of democracy, mainly teaching that power should help the poor and treat them with compassion. What about the atom? Well, he said that all matter was made up of indivisible particles called atomos, which is Greek for uncuttable. The word atom comes from the Greek atomos, which comes from the philosopher Democritus at around the years 400 BC. Skipping to 1808 now with scientist John Dalton, who said that atoms are tiny solid balls like billiard balls. We've all seen them. He published this theory stating four things. Firstly, atoms are tiny indivisible particles. Atoms of one element are all the same. Atoms of different elements are different. And finally, compounds are formed by combining different atoms. Next, we bring along scientist J.J. Thomson, who was one day exploring the world of cathode rays, which are rays of negative charge. To put it simply, this allowed him to discover the electron in an atom. Atoms are made up of three smaller subatomic particles, and electrons were the first to be discovered by J.J. Thomson in 1897. Electrons have a negative charge and an extremely small mass of about 1/2000. But we can describe it as negligible. But what's this got to do with plum puddings? Well, using his discovery, Thomson created a new atomic model known as the plum pudding model because he thought it looked like a plum pudding. The atom is a ball of positive charge which contains negative electrons distributed in it. These look like raisins or plums in the sponge. Two scientists by the names Ernest Rutherford and Ernest Marsden wanted to test Thomson's plum pudding model in 1911. They took some sheets of gold foil and shot beams of alpha particles at them. But what did they predict? If the plum pudding model was correct, most particles should have gone straight through, and some deflecting at fractions of a degree. However, while many particles did go through, some deflected completely back or at large degrees. After 100,000 attempts, Rutherford concluded that an atom must have a positive central mass, which caused the positive particles to repel and reflect back off. Rutherford made his nuclear model in 1911. It contains a nucleus which has its mass and has positive protons. It also has electrons that float around the nucleus. No one really knew what to do with them, but protons were the second subatomic particle to be discovered. This was by Ernest Rutherford in 1911. He knew that the nucleus must be positive as the positive alpha particles repelled it. Protons have a positive charge and a relative mass of 1. Niels Bohr is sometimes regarded to have the biggest influence on the atomic model by figuring out what those electrons are doing. In 1914, he created the Bohr model, which stated that electrons are found in shells or energy levels orbiting the nucleus, and that each shell can hold a certain number of electrons. The first shell with the lowest energy level closest to the nucleus can hold up to 2 electrons, and the second and third shells can hold up to 8. The shells exist at fixed distances from the nucleus. Our final development was a small but important one by James Chadwick in 1932, as he discovered the neutron. The neutron is the final subatomic particles to be discovered. This was by James Chadwick in 1932. Neutrons have no charge and a relative mass of 1. The neutrality of the particle made it the hardest to discover. So, from ancient Greek politicians to modern physicists, that is the atom we know today with 99% empty space and 3 subatomic particles. Thank you guys so much for watching. Don't forget to like and subscribe, and I'll see you in the next one. Peace.